Microplastic is a pollutant that's been found in almost every compartment in the Earth system. And this has led to the vantage point of looking at microplastic also as a factor of global change, where initially this work had been more focused on adopting an ecotoxicological viewpoint. And there are real differences that arise from viewing microplastic as a global change factor compared to just viewing it as an ecotoxicological problem. And this is what I'd like to discuss. So if you think microplastic is predominantly, or should be studied predominantly as a global change factor, then your interest in the concentrations to use in your study shift from what are the current levels of contamination more towards what could be expected in terms of contamination level in the future. This is exactly in parallel to other factors of global change. For example, elevated CO2. You would not do an elevated CO2 experiment by using the current levels, even though of course they've already been elevated over, let's say, pre-industrial times, but you would use a projected CO2 level in maybe 50 years or something to examine what would happen in the future. At the same time, for microplastic then, this means don't use as your target concentration for your experiment currently observed levels of microplastic contamination, but use some, well, in this case it's a best guess what might be in your soil if this contamination continues as it currently is, and given the point that this material doesn't really decompose very easily. At this point, these values are both guesses because we don't have very good baseline values for a broad range of soil types, and we also don't know what the rate of increase is. But the point is that your interest shifts to examining what would actually be happening in the future, whereas the ecotoxicological vantage point is more focused on what are current levels and what are risks given the current levels of contamination. If you take a more ecotoxicological vantage point, your focus is on mostly observing negative effects. How does the fitness or physiology of a particular target organism negatively affect it? If you are viewing microplastic more as a global change factor, then any effect is actually important. It doesn't really matter if the effect is a positive effect, nominally positive effect, so some variable increases, or if it's negative. And this is also in exact parallel to global change effects, where elevated CO2, for example, essentially for plants is a fertilizer. They grow better because it reduces the limitation. But this positive effect is not to be interpreted in a positive way because it leads to changes in ecosystems that wouldn't have happened in the absence of this factor. It's exactly the same with microplastic. We, for example, frequently, but not exclusively, have observed positive effects on plant growth. That doesn't mean this is to be interpreted in a positive light. It just means there is a shift that is occurring, and that shift has to be interpreted negatively because it wouldn't otherwise be there. In ecotoxicology, you tend to focus, not exclusively, but mainly on very highly controlled experiments where you have a focus on reproducibility, on using standardized methods. If you look at the problem more from a global change factor perspective, then the focus shifts a little bit away from this highly controlled, highly mechanistic work, even though it's also highly relevant still to global change biology. But it also then starts to include ecological relevance and to look at effects in ecosystems. And that means also moving away from the very highly controlled lab environment settings. Having the ecotox perspective means often having highly defined endpoints for particular, usually often also model organisms, because they can be worked with reasonably well in the lab. But when you take a more global change perspective, it means you would more likely to choose ecosystem relevant endpoints. like process rates that are relevant or only appear at the ecosystem level, for example. And it may also mean shifting focus away from individual responses of organisms, like particular model organisms like Caenorhabditis or any other model organism for ecotoxicology, but it also means then shifting towards other levels of the ecological hierarchy, including plant communities, for example, rather than just plants, and fungi communities rather than just individual model fungi that you examine. So this doesn't mean either or that one is wrong, or the other one is correct, or that one is more correct and the other one is less correct. Of course, both are very valid ways to view microplastic pollution. I think it's just important to realize that if you take a global change biology perspective on this problem, there are just additional questions that you can ask, and there are additional frameworks in which to place your work. And I believe that is actually quite important because it can help to broaden the scope of this work. Hi there! If you like this video, don't forget to click like down there, and also remember to subscribe to the channel and feel free to leave comments. See ya!